What do you think this is? Does anyone know what that is? Well, it's actually a cattle feedlot. This is beef production, livestock production in Texas, as it happens. And this basically, currently, livestock production, particularly beef production, requires 30% of the world's land mass. It also uses, in the US, and the story is not so different in many other countries, 50% of the water supply. It generates 18% of the world's greenhouse gases. And it also generates water, land, and air pollution. Livestock production, particularly beef production, is also costly and wasteful, sometimes requiring huge amounts of feed, producing carcinogens, toxic waste. And then the industries that are using livestock production, for example, the leather industry, is subject to volatile pricing. We've had a lot of excitement in the last couple of years around the whole area of synthetic meat, the idea of creating a viable substitute for meat, and it always seems to be a hamburger. This is the Impossible Foods Impossible Burger, which is created from soy protein, but using this substance called heme. So it's a plant-based hamburger that bleeds. This generated a lot of press and was following projects like the $375,000 hamburger of Mark Post a couple of years earlier. But if we come from the world of meat to the world of leather, right now it is apparent that demand is outpacing supply. As well as being a key environmental issue, there is also a major global market for leather goods. So this figure of 200 billion actually is not including all areas of leather usage. So that excludes, for example, the automotive industry, which is a very important area. So that's a very conservative estimate. My two panelists here today are some of the most inspirational people that I have encountered working in the area of trying to create a viable and newly imagined version of leather. So on the one hand, we're going to hear about the potential of mushroom leather from Phil Ross from MycoWorks, and then we're going to hear from Suzanne about the work of Modern Meadow, particularly with collagen-based leather. So first, to introduce Phil, who is somebody that I've known for quite a while now, since we first met in San Francisco. And when I first encountered Phil, he was an artist who had just spent, I believe, 8 years living with a mushroom. So he and I think this is something, not the mushroom bit, but the artist bit is something that is closely connected with Suzanne's background, because she comes from the creative design, fashion industry. So both of them are creatives who are now working as entrepreneurs in this space of biomanufacture, biofabrication, which is such an exciting space, as we heard earlier also with the example of the spider silk from Bayreuth. But Phil, as I say, was living for 8 years with a mushroom, and this was a way that he developed all sorts of fascinating techniques to work with mushrooms, with fungi, to create all sorts of interesting new biomaterials. So I'd like to hand it over to you now, Phil, and really ask you, why are you obsessed with mushrooms?
Great. Thank you, Michael John, for inviting me here, and thank you for all the folks who've come to this and for the organization for putting this together. So as Michael John explained, I've had this now something like a 25-year relationship with various types of mushrooms, which started off as an aesthetic inquiry as to how we recognize an organism's expression in the world and to understand its difference. And that particular obscure area of study then led to an understanding of the physiological expression of these organisms in distinct environmental systems. One of the primary mushrooms I've been working with over this time is a wood-degrading fungus. You would probably find this very close to this location. Anywhere that there are trees, this type of mushroom exists. Human beings have been using this mushroom in documented form for over 2,000 years in traditional Chinese medicine, and it probably goes much deeper into our prehistory. These types of fungus are natural immune stimulators. They make our T cells proliferate and have a lot of other types of biochemistries that have been very beneficial to humans. These have also been used as a type of tinder starter for preserving fires and other types of things, and have also had a very traditional type of craft, even here in Germany, pounding out these types of fungus to make a type of felt. And there's documented evidence of making these into lederhosen and other kind of traditional dress. So my initial organization with this, or introduction to this, was through the medicines. In San Francisco in the 1980s, there was the HIV crisis, and before there was the development of any of the antiretrovirals that are now quite typical, there was only palliative care, and there was this traditional Chinese medicine, or whatever people could put together. So I had a lot of experience collecting mushrooms for edible purposes. I trained as a chef, so I had this interest in the differences of flavor and all that sort of stuff. And when I started to participate in the initial pot clubs in San Francisco, I realized that I could contribute by bringing these mushrooms in from the wild and bringing this type of natural medicine in to complement the marijuana that was also being used as palliative care at that time. It was too difficult to collect these from the wild, so I used my chef's training to teach myself how to grow mushrooms. The process engineering is not that difficult from large-scale vegetarian cooking. And so I began to grow these to cultivate this type of medicine. And eventually, after many, many years of association with this and using it as an artistic medium, using it as a medicine, thinking about it for other sort of abstract aesthetic qualities, a lot of industry started to approach me as to what these things might be useful for. They turned out to have quite remarkable types of material qualities. So the variabilities of the expression of this organism can be very dense, it can be very porous. It really is a type of plastic. You might ask, what are the qualities of plastic? And the qualities of plastic are what you want it to be. And then you will engineer it to be that way. And so this fungus is very similar. It has a very plastic sort of response. And all you have to do is change the environmental settings to have that expression come through. You see these examples here of this type of mycelium leather that we grow. We grow this on agricultural waste, things that have no other types of value, things like sawdust or corn cobs or hemp hurd or other types of cellulosic materials. These are cultured, and then we can produce this somewhat leather-like material, something that we've engineered to behave and perform like leather. So we can do this with about 10% of the energy and the water, and it even becomes a carbon sink for these materials over time. So we've been able to create this in aesthetic forms that people find pleasing. It's very pleasant to have in your skin. It's actually beneficial to have against your skin. And it has the aesthetic qualities that people like. It breathes, it has, it feels warm to the touch, and you can make it as soft or as slick as you would like it to be. So I incorporated with two other founders about 3 years ago to create MycoWorks. We're based in San Francisco. I am one of the CEO currently. And we're just getting ready now to scale up to produce these for industry. So we've doing the prototyping to prove that you can actually use this as a type of a drop-in into traditional leather crafts. So we've taken it from a rather crude state about 18 months ago to now the point where you can use it with industrial sewing machines. It's flexible, it's waterproof, it has all these other sorts of things that we've been able to use green chemistry into it to modify the mycelium to, again, to feel and behave as if they are like mushrooms. This is what you would call a closed cycle or maybe a closed loop type of manufacture. So you can take, as you see on the top here of this illustration, you can take something that has grown, some vegetal matter. After it's died, you can cultivate that with this fungus. You can generate these leathers, which you can then manufacture into useful objects. And when those useful objects are done, they can be recomposted, added back into the soil, and in fact become some type of nutritional element for the next generation of production. So I'll probably, I think,
Thank you.
keep that short.
So, well, before we finish with you for the moment, just one question. I mean, these are quite beautiful and smell a lot more like leather than like mushrooms.
Yes.
But we are sitting here in Bavaria today, so how soon can we expect to see mushroom lederhosen on the market? Is it going to happen?
As soon as the market demands it, we will be there.
Do we think that it's likely to take off, the mushroom lederhosen?
Yeah, we have, oh, wow.
So thank you so much, Phil. But now, before we discuss further, I would like to go to Suzanne. So, Suzanne, you right now in MoMA in New York, there's a T-shirt that you've created in Paolo Antonelli's amazing exhibition, 100 Items, looking at icons of contemporary fashion. It's exciting for me that you have a T-shirt being exhibited in an art gallery for the first time. But before we get into that, maybe your process is all about collagen. And when I think of collagen, I suppose the first thing that pops into my mind is probably Julia Roberts' lips. So maybe can you tell us a little bit about what collagen is and how this is helping you to create a different approach to making or reimagining leather than Phil's approach with mycelium?
Yeah, so collagen is, I mean, for women in the audience, maybe the association is more around skincare and aging and wanting to replenish collagen. So collagen is the principal protein that we find in our skin, but also animal skin. So the main structural component of leather is actually collagen. Can I borrow the clicker?
Yeah.
So you're right, we grow collagen. As a company, Modern Meadow is very much about bringing together design, biology, and engineering. The way we do it is we use a yeast cell, so in a process very similar to brewing beer. We start with yeast, and we design and engineer that cell with the DNA sequence that will produce a specific type of collagen protein. And we multiply those cells, we ferment a collagen production system, and then we take that collagen, purify it, and assemble that collagen into a structure. And so design, biology, and engineering is sort of throughout that process. And we can create materials that look very much like a traditional animal leather. So these materials are in a sheet form. They can be processed into all kinds of colors and textures. But as we create that, the definition of leather is that it comes from the hide of an animal, right? So our process has nothing to do with animals. It's completely animal-free. So one of the questions from the beginning of the company was, what are you going to call these materials? And last year we went through a whole process of trying to figure that out, and what we settled on was Zoa. And Zoa comes from the Greek word zoe, meaning life and organism, and really sort of focusing on growth. So we are, as a company, interested in growing materials that can have, we're working with the building blocks of nature, but we're interested in doing things that nature cannot do. So as we think about mastering those materials, how through design can we also go beyond what nature has done? So with leather, you're very much tied to the skin of the animal. It's very much a found resource. It comes in a certain size and shape and a certain sort of structure. And through the process with MoMA, we created a whole series of prototype materials. So this, for example, is a composite material where we have our collagen solution on another textile. And what you're seeing there, the black and white, is actually leather in a liquid form coming together, where we bring black leather and white liquid leather and we marble it. So we could even create a solid cube of leather, and if we sliced through it, you would see those colors all the way through the material. And so as we push that even further, we think about materials that what does this open up, this field of sort of growing the protein itself? How do we then take that protein and organize it into a material? And from a design perspective, we can go right back to the beginning. As we have collagen in a liquid form, can we then take those nanofibers, dye them, tan them, and spray them like a mist onto silk? So what you're seeing here is a leather mist on the finest, most drapeable silk, and actually is nothing like leather, but it's the same component of leather. And then even further beyond, as we think about working with liquids, well, why do we even need to create a sheet of anything? So this is almost painting with it and thinking about leatherizing surfaces. What if we could actually graffiti with it, paint with it, apply it only where you want it? So you start to think about leather from a performance perspective or from an aesthetic perspective, and it opens up a sort of new toolbox of creativity for designers. So I would like to just finish with a little film that sort of speaks to the MoMA project. This is what you were referring to that's on display at MoMA. That T-shirt really comes together not as just a leather material, but rethinking what leather can do. So here, instead of stitching the T-shirt together, we've used liquid leather as a manufacturing technique. So we took a T-shirt apart, we substituted 2 new materials in. So at the neck and at the hem, there are new fabrics that come together, and the liquid leather is joining it all back together. So it's both a material, but also a new way of joining and creating product. And as you say, that's on display until the end of the month. And this is the film that accompanies the project. Oh, no time?
Sound, please.
Can we go back?
Phone. Yeah, good.
There should be some sound. Yeah?
Thank you. Wonderful. So I have a question for both of you, really, which is how much of this is driven by ethics and how much of it is driven by the market? I mean, we have a craze for biofabrication right now, and there's accelerators all over the place. We have folks like IndieBio who are here. There's a huge amount going on. We heard about spider silk early on. I mean, is it driven by these big environmental challenges, or is it market-driven, or a bit of both?
I think it's both.
Yeah, I believe it's a bit of both. The foundation of MicroWorks was not predicated on any ideological or ethical foundation specifically, but it was very much out of a consideration first of how environmental systems work. So I think it was just coming from the field of study itself, of thinking about how organisms utilize resources and sort of just following that same type of model.
And I mean, leather, correct me if I'm wrong, but it's basically a byproduct of the meat industry, right? So how can we address these environmental challenges if we don't simultaneously reinvent the meat industry?
I mean, that's a huge issue, right? You showed some data right at the beginning there around how demand is outstripping supply for one or the other. I don't know that either of us would claim to try and replace either of those industries overnight. Certainly, the size of the leather industry is enormous, and so long as people are going to eat meat, you need to deal with the skin of the animal. So until we reduce meat consumption around the world, there is always going to be a market for, or a need to deal with those skins. I think maybe what we both share is seeing a new opportunity that is indeed driven by the market. So certainly one of the drivers for the foundation of Modern Meadow was coming from fashion companies who were actually saying, is it possible to grow the skin of an animal instead of needing to raise a whole animal just for its skin? Could we actually create the material using the tools of biotechnology that we see that can produce human skin, for example? So those early provocations came from the fashion industry to our founder, Andras Forgach. But he also was living in China at the time, and he was very much seeing a sort of emerging affluent consumer who was looking to eat more meat and buy leather products. So the sort of two things, I think, were drivers for founding a company like Modern Meadow.
Yeah, and I think there's going to be something like another billion people on the planet in the next 20 years, and the animal populations will grow with the human populations. That in terms of the projections for the next 30 years, there's only going to be an increase in all living organisms on the planet. Those next billion people are going to have to wear clothing and eat food and all those other sorts of things, and it's going to it will have to come from other sources beyond animals. So yes, I would agree. It's like it's not a replacement for animal products or for, say, polyurethane sheet materials or other things like that, but it is another analog. It's something else that can be added to those variety of materials.
And I mean, one of the things that I think you touched on quite a bit, Suzanne, in what you were showing was the idea that in a way leather is only the beginning, or it's a way to connect with ideas that people already have. It's a category that people have, and the real chance in a way is to go beyond leather and to, you showed images of liquid leather and marbling and all of these things that actually are impossible in nature. And I think that's interesting. It's a bit like with the food where people, the hamburger is something familiar. If you present people with lots of strange looking things on a dish, but it's actually fantastic to eat, then it's confusing. So is that something that both of you are striving for? I mean, things that have never before been imagined in terms of whether it's in furniture or fashion. Can you speak to that?
I mean, obviously for us as a technology company, there's a lot of discussion with big brands, whether it's fashion, automotive, interiors, wherever. And when we start to reveal some of the discovery that we're making, some of the thinking that comes, through, the sort of, the discovery of what we're working on, and the fact that we have it in a leather form, in a liquid form, suddenly they also shift. It presents new opportunities for how they might form a product, right? And I think, there was a great presentation earlier with one of the designers from Mini rethinking car seats, for example. And, one of the challenges for a leather interior for a car is that you need the leather to do lots of different things in different places. So to support, to stretch. There's lots of stitching and seaming involved. So if we could create that seamlessly, then there are opportunities that come through these materials that are really different when you're only working with a 2D sheet of material. So in the beginning, maybe we thought we were making something more akin to traditional leather, but over time, it sort of starts to surface all kinds of new design and product opportunities.
Yeah, and I absolutely. I mean, we have made this look and seem as if it is an animal leather because that's what people want. And that seems there's a huge market for this already. But we can grow these with electronics inside of the material. We can grow them with carbon fiber inside of them. We can grow them with drugs inside of them. We can grow, there's no upward scale limit, so we can do things that are impossible with animals. We can grow a sheet of that as large as this room if we had the ability to do so, the manufacturing process to do so. So you can imagine that we would be able to make airplane wings or monolithic boats or other types of stuff where you could imagine what a skin would do if you actually had an animal that large, but it's just beyond our imagination right now of a single sheet of stuff. And ultimately to things that will have qualities that are incredibly novel, maybe being computers or robots themselves in these types of materials.
Well, I'd like to open it up to the audience in a moment for one or two very quick questions. But before that, earlier today, it was a session, I think, with Hans-Ulrich Obrist discussing virtual reality and art, and there was people were talking about Robert Rauschenberg and the 9 evenings of art and technology, and how artists are like the antennae in a way, the seismographs, as I think Hans-Ulrich Obrist puts it, for new technology, and are pioneers and explore the territory that is sometimes not so available to others. Is that the way you guys see what you're doing? I mean, obviously you've come from fashion design, which is a slightly different discipline, but Phil has come from fine art. But it's interesting that you're now propelled into the world of the market and the world of the startup. So can you speak to that?
I mean, yeah, for me, it's been a very long journey, sort of out of one industry and into another, and then actually coming back round again. But I think for me, it was a sort of light bulb moment when I realized that biology was a tool that, in the hands of designers working with scientists, had the most abundant creativity I could ever imagine. And the real opportunity for a designer was to get involved right at the start, because we're building materials from the bottom up. And if we're going to reimagine a shoe or a handbag or a jacket or a chair, whatever it is, the material itself and getting involved in the design of that structure and how it forms is all part of the design process. These kinds of materials really show their function and aesthetic when you have that in mind at the beginning of the process. So instead of the designer coming in and just working with materials that we found off the shelf, the real innovation opportunity happens when design starts right at the beginning and is reimagining that product and then formulates a structure or a way of growing something that can deliver exactly what you want and nothing else. Incredibly efficient.
Phil, very quickly.
About the creativity and why designers or artists might be into this field. We've been talking about this a little bit as to why people coming from design or the humanities are acting as biotechnology executives. It seems somewhat strange. But certainly I think it's when you train in the arts, you have to be given a situation where you're unfamiliar maybe with materials that you have never worked with before, and you have to create some type of meaning out of them in a context for a population that you're surrounded by. This is also the perfect training for an executive, is to make up their decisions and be creative with the situation at hand and to come out with some type of success out of that. So I wouldn't say that, if you want to study business, you should go to art school, but I think for what people are always talking about in creativity, certainly it's that ability to take things and put them together, find the right talents, create the stories, or find the mythologies that fit well with what you're doing, so that people will welcome it.
Wonderful, and that's actually linked to one of our goals in Biotopia, which is the space that we're creating here in Munich, which will have, among other things, a bioart and design studio to try and encourage a new generation to engage with these materials. But we're almost out of time, but I would love to have one or two questions from the floor. Yes, please.
Yeah, sure. I mean, we have been, us humans have been working with animal leather for at least 500,000 years or so, and probably even longer than that before we were humans. We were also probably engaging with this. So, to have 18 months to kind of catch up is a bit intense. And so, there's the performance that is absolutely necessary for things like shoes. It's a very demanding type of leather. The performance and tolerance of them are extreme. We expect to be there in about 2 years for that type of thing, and then ours is based very much on the ways that you would grow edible mushrooms for food. So these are already scaled industries that have giant climax size factories. So ours is a relatively low tech process, so it is scalable, and so it'll just be a matter of how fast that can be scaled.
Yeah, I mean, I think footwear clearly is a massive opportunity for anyone who's producing an alternative to the existing materials, whether they're synthetics or leather. They also have extremely high performance needs. So I'm sure, we're all going to get there at some point. Whether a shoe is the first product or not, I think remains to be seen. But for sure, it's a big opportunity, and I'm sure there's a lot of people prototyping those types of products. I think the success of any new material, to some extent, you can expect existing manufacturing to change a percentage, but it also needs, to some extent, to drop into existing manufacturing. So there are definitely challenges there around really prototyping and working within existing systems to figure out how you can bring that material to market faster.
Great. Unfortunately, I'm getting a sign that we have to end there. I'm sorry. You had maybe a very short question. If yes. I think Phil already touched on that, and I think Suzanne is also someone who's come from a very strong wearables background. But as we're completely out of time, I'd suggest that you come and talk to them. These are two absolutely inspiring people. Come and talk to them. You can touch Phil's mushroom leather, I'm sure.
Touch the leather.
Allow
yes,
you. Suzanne, unfortunately, doesn't have her T-shirt. It's still in MoMA. But I'd like you to join me in very warmly thanking our two great panelists, Phil Ross and Suzanne Lee. Thank you very much.